Okay, so in this video we're going to look at the quadratic formula. We're going to look at how to use it in an efficient way. So the quadratic formula is very difficult, often people say, to remember. Don't worry about that. In this video we're going to keep it very simple. We're just going to take an expression like 3x squared plus 5x equals 2. Now, let me just make that a bit clearer. I think my plus sign got a bit muddled there. Okay, 3x squared plus 5x equals 2. First thing we need to do is put it equal to 0. So if I subtract 2 from both sides, I'll then bring that over the other side, and 2 minus 2 is going to be, oops, there we go, is going to be 0. So we've got 3x squared plus 5x minus 2 equals 0 to start with. Okay, how are we going to use the quadratic formula? Well, first of all, the bit of the quadratic formula I'm going to use is called the discriminant. So I'm going to start with just part of the formula. So I'm going to use the discriminant. Sort of work out. So nice and easy though to remember this part of the formula. Let's just use this kind of here. So what we're going to remember is b squared minus 4 times a times c. b squared minus 4ac then. Okay, so using the discriminant, using this little formula here, and you'll see why it works in a moment, you'll see why it's part of a larger formula that's just a rearrangement of the whole quadratic equation. So we're going to use this bit here. b squared, well, b is this bit here, so that's b. This bit here, the coefficient of x in other words, is then a, and this is c, so c is minus 2. a is 3, b is 5, c is minus 2. So using the discriminant then, we've got b squared, well that's 25. Take away 4, and instead of times, because there's lots of x's flying around here, I just want to use brackets for this. I'm going to use 4 times a, which is 3 here. And again, using the formula, go back to c. c is minus 2, negative 2. So negative 2 in brackets, like this. And that gives me a value. Now, 25 minus 4 times 3 is 12, but times a minus is going to give me a plus. So plus 24 gives me the answer of 49. And this answer is what we then need to use when we're, well, we can use it in lots of different ways. When we're trying to ask ourselves, for example, are we going to use factorization? Are we going to factorize to get this answer? Well, if this one is a square, so if this number is the square of an integer, and it is, because it's the square of 7, so 7 squared is 49, then, so is it a square? Is it a square number? If it is, then we know that we can factorize. Now you can't always factorize to solve these problems, to find x. So if you're in any doubt or you want to speed things up, you're going to use the quadratic formula. But in this case, we've used the quadratic formula to this case. We might then decide to leave the quadratic formula and solve it by using the method that we've used before. And let's just show you that that works. So is it a square? Yes. Can I then factorize to solve this? Yes, I can. So you'd use a method something like this. So if we do a bit of scaffolding here, we've got 3 times minus 2 to get our product, so that's minus 6. And then we've got our sum, which is this number, so they've got to add up to 5. And we've got 1 times minus 6, well that won't work. 2 times minus 3, 3 times minus 2, it's going to be 6 times minus 1. And that's because 6 times minus 1 gives us minus 6, but it also adds to 5. 6 minus 1 is 5. So here are our numbers that we were going to use then. And maybe we'd make a little grid to organise our thinking here. Fill in what we do know. So we know that these parts, we know 3x squared, and we know this bit is minus 2, negative 2 down here. And we've now got our numbers, so we know how to split this middle term, which is the essential problem that we've got here when working backwards and factorising. So we've got 6x minus x, giving us our 5x term here. And so this has got to be the product of 3x and x, giving us our 3x squared. This has got to be the product of 3x and 2, so we've got x plus 2 now, so 3x times 2 gives us our 6x. And this has got to be the product of x and minus 1. So we've now worked backwards to find our factors, and we know then that this expression has got to be x plus 2, can be factorised as x plus 2 times 3x minus 1, which equals 0. And if we know that, we can then say, well, using the zero product rule, x plus 2 equals 0 is one option, so x is going to be equal to negative 2. Or 3x minus 1 equals 0, so 3x must equal 1, therefore x must equal a third. So that's if we've used the quadratic formula partly to find out, well, is it factorable, and therefore if it's a square that we get here for our discriminant, we can use the factoring method and get our solution that way. But what if we don't? What if we don't depart from the quadratic formula? Well, I'm going to show you that step now. So instead of going off in this direction, we're now going to continue to use the quadratic formula. So what is the full quadratic formula? Let me write it out in full and you'll see. So erase this bit now. So the full quadratic formula starts with this discriminant, like this, but we put this now under the square root sign. So all you've got to learn is the discriminant and then realise, well, okay, if I get the discriminant, all I've got to do is put it under the square root sign. So x equals, I'm going to leave a little gap here, the square root sign and the discriminant underneath the square root sign. Okay, now the next bit is plus or minus. Because if you square root anything, if it's just a square root, not a cube root, then you've got two options. You've got a plus 7 in this case, or a minus 7. So you have to use this plus or minus sign. So that's the next thing of the quadratic formula that you need to remember, but fairly easy to remember because it works, because it's one of those rules about square rooting. Okay, now the bit up front that people struggle to remember is minus b. That's all it is, minus b. And the final bit of the quadratic formula is the underneath bit, and again that's easy to remember, it's just 2 times a. So as long as you can remember minus b and then underneath 2 times a, pretty easy to remember that when you're working this through, minus b, so minus 5, and underneath here 2 times 8, so 2 times 3, which is going to be 6. So really much quicker than working in this way, and this will give you your answer exactly the same as we had here. So let's see that actually works. So we've got minus 5 plus let's just use the plus here, plus 7 all over 6, or, so we've got two solutions, minus 5 minus 7 all over 6. Therefore, x equals, well, minus 5 plus 7, that's going to be minus, it's going to be plus 2. So 7 minus 5, in other words, plus 2. So just 2 over 6. x equals, or x equals minus 5 minus 7 minus 12 over 6. And so now we've got a third, and here we've got minus 2. So we've got exactly the same solutions as we had here. In fact, what we've got here, you might say, is a way of checking. If we've used this method, let's use the quadratic as a way of checking. But anyway, we've got the solutions both ways, and it's up to you to decide which one you find easiest. But here we've used the quadratic formula, the full quadratic formula. But instead of trying to plug in all the values straight away, we've started with the discriminant, then we've done our square root with the plus or minus in front of it, then we've filled in our minus b and divided by 2a to get our solutions. Okay, so if we call this problem A, let's try it again. Let's try with perhaps some more interesting numbers. Let's try 10 times something, so 10x squared minus x, and then it should work out nicely if I go minus 24. So equals 24 or minus 24 equals 0. Okay, so first of all, what do? Use the discriminant. So it's all of this underneath the square root sign, which we memorize. B squared minus 4ac. So using the discriminant, sometimes abbreviated delta, but we might as well write it out in full, doesn't take very long. So using the discriminant now, we've got b squared. So we've got, for b, we've got minus 1. Sometimes it's good to just put these values so we don't get confused, especially with the minuses. So we've got minus 1 is our b. Here our coefficient is 10, so that's our a term. And here we've got negative 24. So I'm just doing it in another colour so I can quickly glance at these and speed things up a little bit and avoid mistakes. Okay, so b squared is minus 1 squared. So I might as well do it like this. B squared minus 4 times 10 times the last one minus 24. And what's that? Okay, well we've got 1, because minus 1 squared is 1, minus 4 times, if I combine these brackets here, I've got negative 240, so times minus 4 is going to give me positive 960. And my total there is 961. Now this is where you want to look at this and say, well, is it a square? Is it a perfect square? So is 961 a perfect square? And it helps if you know your squares to a fairly high value. This is in fact, I believe, 31, but I'm not going to just take my word for it. Let me just check that I've got that right. So 31 times 31, go to one side here, plenty of room here. 3 times 1 is 3, 3 times 3 is 9, and then I've got 31 underneath. So there we go, 961. So there's my little check that this is the square of 31. So that means I could go ahead and use this method here, or I could immediately go to use the quadratic formula. So this time, so you might want to go through this exercise of checking it this way. It's a good idea, it gets you your check. But in the interest of time, what we'll do here is just go ahead and use the rest of the quadratic formula. So we start with x equals, we put our 961 under the square root sign, put our plus minus in front, and minus b. So that's minus b. Well, b is minus 1, negative 1, so minus b is going to be just 1. So nice and easy, 1 plus or minus square root of 961 all over, put our fraction bar here, 2 times the first term, a, so 2 times 10, 20. Okay, so what does that give us? Well, we know that 961 is 31, so it's 1 plus or minus 31 over 20. and that's going to give us, so let's just put, there we go. Let's start another line as it were, but I want to keep plenty of space to do another one maybe. So therefore x equals, so 1 plus 31, so that would be, let's do 1 minus 31 actually, so equals, so let's make that a bit clearer. It should be a therefore sign, so dot, dot, dot. So therefore x equals, well, 31, 1 minus 31 is going to give me a negative 30 over 20. Here we go, that's our first one. And x equals 1 plus 31, 32 over 20. So I've got x equals minus 1.5, so negative 3 over 2, and x equals, now let's just simplify this, so we've got 16, divide by 4, so we've got 8 over 5, so 8/5. And we're done. Okay, let's see if we can squeeze in one more. So another reason for doing this is just because of the space saving. There we go. Because it saves quite a bit of space. So I'm going to try and compress this now just to show you how useful this can be. Let's again though do quite a complicated. There we go. Let's get our pen. So quite a complicated thing that would challenge quite a lot of students. Let's have 9x squared plus 14x minus 8. So equals 8 or minus 8 equals 0. So using the discriminant. Alright, I'm not going to write that out this time. I'm just going to use my delta symbol. So using the discriminant now, we've got b squared. I'm not also going to write above. We can see it fairly clearly. So b squared. So 14 squared, well 14 squared. You want to know your square numbers. If you're not sure, just use your calculator. 196. So it's 196 minus 4 times, well, it's going to be plus 72 because negative 8 times 9 is going to be 72. So it's 4 times 72. So 4 times 72, well, it's going to be 144, 288. So we've now got 196 and plus 288. Is that right? Yes. Okay, we got that right. So, just in the interest of time, what we're going to do is bring this up to 200, and then we can bring that down, then increase that by 4. So that went up by 4. So this one comes down by 4 to become 284. So we've now got 484. Okay, so x must equal, so if we use our 484, square root it, put our plus minus symbol in front, then we've got minus b, so that's going to be minus 14 divided by 2 times a divided by 18 then. Okay, so now we're near our solution. 484. Now 484 off the top of my head is 22 squared. Let's just check that. So 22 times 22. Okay, let's have a look. 2 times 2 then is 4. 2 times 2 is 4. 2 times 2 is 4. 2 times 2 is 4. We've got our 484. So quite an easy one to remember, but just to double check there. Okay, so we've got 22. So it's minus 14 plus or minus 22 all over 18. And finally then, we've got, so x equals, so therefore x equals minus 14 plus, oh let's do negative, so minus 14 minus 22, so that's going to be minus 36 over 18. So that works out rather nicely. And we've got x equals, well, we've got minus 14 plus 22, so that's going to be 8 over 18. These simplify to minus 2, and this one simplifies to, well, if we halve both top and bottom, we'll end up with 4/9. Okay, but now just finally let's have a look at where this comes from. Let's have a look at how we form this quadratic expression and where this discriminant comes from. So I know we've gone over this, so this is a bit of a recap from the previous video, but it's worth recapping. So I'm going to just write it out again in its general form. So so this is the quadratic equation, any number a times x squared, plus b, any number b times x, plus c equals 0. And in fact, immediately before I write that, I'm just going to put equals minus c. Okay? So first of all, we put it in this format. So we start here. Now we need to get an x. We want x to be the subject, and it's quite a difficult operation to do, but let's go through it, and you should see how it works now. So what I'm going to do first of all is get rid of this coefficient of x squared by dividing through by a. So now we've got x squared. A divided by a is 1, so that gets rid of my a. But now I've got the a everywhere else, so I've got b over ax equals minus c over a. Okay, now the next step is to use what we call completing the square. And that's when we turn the left-hand side into a perfect square. And we can do that, let's have a look at it as a grid. We can do that simply by, let's put it over here. If I draw my, let's make that a bit straighter actually. If I draw my grid out quickly, like this. Now what I'm aiming to do is make a square. That's the key idea here. So I've got x squared, that's okay, that's fine, but if I have different values here and here, then I won't have a square. So the key thing is to make sure we split our middle term here. We've got a plus 0 if you like, but split our middle term into half of b over ax, so b over 2ax, so bx over 2a I should say, added together would give me my b over x. So that's fine. But what I need to do to make it into a perfect square is I need to have a term here, which I'm going to then add to both sides. So what's that term going to be? Well, we can simply get it from factorizing. So if I put my side terms here, I've got b over 2a, b over 2a. So that's okay, but the fourth quadrant now would be the product of b over 2a times b over 2a, or b over 2a squared. So in other words, b squared over 2a squared, which is going to be 4b squared, like that. So now I've got this extra term here. This is the completing the square part. I've completed the square, so I just add that now to both sides. So plus b squared over 4a squared. And on the left hand side, I've also got b squared over 4a squared minus c over a. So it's that bit that people struggle with, but once you've done it a couple of times, hopefully that becomes quite clear. Now, that means that what I have in this grid here, this whole expression here now, I can square root. So I get x plus b over 2a. So x plus b over 2a. And just for the moment, squaring it means I've got exactly the expression that I have here. Okay, now, on the right-hand side, before I do anything else, I want to make common denominators. So I want to make this, and it's the right-hand side we're going to be really interested in, I want to make this the same as this. What have I got to do? Multiply this by 4a, and I will have 4a squared. So I have to do that to both the denominator and the numerator. So now I've got b squared over 4a squared minus c times 4a, and here I've got 4a times a 4a squared. So there we go. Nearly now got my discriminant. You can see it forming, but we need to do one more thing, which I'll just do over here. To be able to see it happening, we need to combine these terms now. So we've got a common denominator now of 4a squared, and at the top we can just happily join them together now. We've got b squared minus 4 times a times c, so c 4a or 4ac, so minus 4ac. There we go. And there's our discriminant. Now, on the left-hand side, we're then going to square root, so we end up with x plus b over 2a. And so we have to square root this side. So we're going to square root the top, which is b squared minus 4ac. And by the laws of indices, we can, and the surds, we can also split this into squaring the top and squaring the bottom. Now, if I square the bottom term here, 4a squared, that will give me, well, the 4 square rooted gives me 2, and a squared square rooted gives me just a. So I don't have to write the square root sign on the bottom, I just write 2a, because 2a squared is 4a squared. Okay, so now we really have got something much closer. We've seen how the square root sign comes into our equation. And we've even got our 2a at the bottom, but we've got all this gubbins over on the left. So let's complete now the process. First of all, we need to remember this plus or minus. When you're square rooting anything, the solution is going to be plus or minus. So there we go. Now we've got our x, and we've got our negative. So if we bring that over, we've got negative b all over 2a. So x equals minus b all over 2a plus or minus our square root of b squared minus 4ac all over 2a. And so, nicely, we've got common denominators. And that means we can join it together. We end up with x equals minus b plus or minus the square root of our discriminant here, b squared minus, whoops, missed off the c, minus 4ac all over common denominator of 2a. So that's how we do it, and I know that's a recap from the previous video, but hopefully it's a useful recap, and it's a way of seeing our discriminant forming. First, where we could see it here very clearly, b squared minus 4ac, then the square root comes in here, and then to complete the formula we now need to take this over to the right hand side, and we end up with our very familiar quadratic formula.